Hello friends, welcome to my channel LahariLectures. In this video, you can watch notes on fourth one round robin algorithm. This algorithm is considered as a primitive version of FCFS algorithm, which is especially designed to be used in time sharing systems. Preemption, that is, switching between various processes, is carried out by creating certain time intervals called time slices or time quantums whose typical value lies between 10 and 100 ms in length. Based on these time slices, CPU is allotted to the processes present in the ready queue, making the ready queue act as a circular queue. These processes uses the CPU for one quantum of time, and then the CPU is allotted to the next process. In a ready queue of RR scheduling, new processes are added based on FIFO queue. Starting from the head of the ready queue, each process is allotted with certain time interval, time slice and dispatched. During the allocation of CPU to the process, either of two situations can arise. First point, the process completes within the time slice and the scheduler simply allocates the CPU to the next process present in a queue. Next point, the process does not complete its execution within the time slice. In this case, an interrupt is made and the process is jumped to the tail of the ready queue. Now the CPU is allocated to the preceding process. The average waiting time associated with each process of RR scheduling algorithm is long. For example, consider a set of processes whose CPU burst time are as follows. Process CPU burst time ms: P1 25, P2 4, P3 4. Let us assume the time quantum as 5 ms. In this case, P1 is first allocated with CPU for 5 ms and then it is sent at the tail of the queue. P1 requires another 20 seconds to complete its execution. Now, the CPU is allocated to P2, which returns it in 4 ms because it needed only 4 ms to complete and hence it quits before the expiration of time slice. Now, the CPU is allocated to P3, which also requires only 4 ms and hence it also quits before expiration. Now the Gantt chart will be as follows: P1, P2, P3, P1, 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 0, 5, 9, 13, 18, 23, 28, 33. Waiting time for process. P1 equal to 13 minus 5 equal to 8. Waiting time for process P2 equal to 5. Waiting time for process P3 equal to 9. The average waiting time associated with the above set of process can be computed. 8 plus 5 plus 9 by 3 equal to 22 by 3 equal to 7.33 ms. None of the processes allowed to use the CPU for more than one quantum. For this reason, this algorithm is dependent on the size of time slice. It acts as a typical FCFS algorithm in case of large time slices, whereas in case of two small time slices, the algorithm is referred as processor to sharing with the speed of value of real processor speed.